Big news in the last couple of days for fans of Betelgeuse. Sorry to disappoint, not that one, this one. Betelgeuse is the 10th brightest star in our sky and the brightest at near infrared wavelengths. The star is a red supergiant around 800 times the diameter of our Sun, about 10 times as massive, and only 400 to 600 light years away. Betelgeuse exhibits a lot of variability in its brightness on a few different timescales, with the main ones being a 400-day cycle and another on a 6-year cycle. Betelgeuse underwent a dimming event in 2019 that astronomers thought might be the beginnings of a supernova. That turned out not to be the case, and Betelgeuse gradually regained its former brightness. Astronomers now suspect that the so-called Great Dimming was the result of an ejection of dust from the star that temporarily dimmed its light. All this variability and strangeness going on were pretty good indications of a companion star for Betelgeuse, and the Great Dimming gave astronomers renewed interest in figuring out what was going on. Models for a companion star suggested it would be very close to Betelgeuse, meaning it would be very hard to observe directly, but scientists at Hawaii's 8-meter Gemini North telescope have managed to do exactly that. Using a technique called speckle imaging, the astronomers were able to make a direct detection of a companion star for the first time, as you can see in this image. The speckle imager on Gemini North is called Alopeke, and the basic strategy is to take a series of very short exposures of an object to effectively freeze the atmosphere in place and allow the telescope to operate at its theoretical maximum performance rather than at the limit dictated by the variable conditions in the atmosphere above the telescope. Because the exposures are so short, this only works with very bright objects, but luckily Betelgeuse fits that bill. Some fancy processing is applied to the data, and then astronomers are not only able to detect the star, but also provide a remarkable amount of detail. We know the companion star's brightness, its mass of around 1.5 solar masses, and the fact that it's close to Betelgeuse and a relatively young star that has not yet started burning hydrogen in its core. The characteristics of the observed companion do a great job of explaining all of the variability we see in Betelgeuse, so a mystery that's puzzled astronomers for at least 200 years has finally been solved. The detection is a little weak by astronomical standards, being only 1.5 sigma, or about 93.5% certain. Astronomers generally like a 5 sigma result, meaning they're just about 100% sure of the detection. In any case, this is a great observation, and follow-up observations should be able to confirm the presence of the companion with more certainty. The paper by Howell et al. Was published in the Astrophysical Journal Letters on July 24th. That's today's video. Please drop a like and subscribe before you click away, and I will see you back here in the next one.